Well, hello internet. Now in this video we'll be learning about interpolation, about spatial interpolation, how we can do that. First let's set our settings. First our environments. I'll be setting these according to my need, so I'll be providing the files about the manual and data. Okay, let this be my current workspace, and an output coordinate system. I will be using from the spatial data interpolation data. From the soil nutrients data, I'll be using this as my output coordinate system. Okay, and processing extent, let's keep it to let's see, same as processing boundary, but we don't see that, right? So we might have to first set the, okay, it should be fine. Then let's set the raster analysis. From in raster analysis we'll be setting as specified below. It should be 20, right? Yeah. Raster analysis 20. Then geostatistical analysis, we'll be setting it to remove all. Okay, so that's for the geoprocessing environments. Now you want to make sure from extensions you enable these 3D analyst and spatial analyst, and also geostatistical analyst, so then only this will work. Now let's add some data, okay, and then we'll carry on from there. I'll add the soil nutrients data. Add. Now click on the Arc toolbox icon. This will load the toolbox. It's under analysis tool, proximity, create Thiessen polygons. Either you can do that way, or the easy one is that the spelling? Thiessen? Yeah. You can just search for that and then create Thiessen polygons. We'll be using soil nutrients data as the input data, and the output, I'll be saving all the output here. Let me create a new folder. It will be called Spatial Interpolation. So what we're doing here is interpolating the data from given points, interpolating more points from the given points. So I think I should name it a Thiessen. Let's see. Thiessen nutrients. Okay. You can name it anything. Okay, then there we go. We can get the Thiessen polygons from here. You might already know the concept of Thiessen's polygon, how these are created by drawing perpendicular from those points and then interpolating those data. So that is by Thiessen's polygon. We have interpolated using Thiessen's polygon method. Now let's do this by IDW method. So let's simply search for IDW. IDW stands for inverse distance weighted technique. So we'll input the point features and let's see what our Z value field should be. It should be ZN. Output raster, we will be saving it inside Spatial Interpolation, right? Yeah. So inside output Spatial Interpolation, we'll be saving IDW nutrients. Okay, let's just name it IDW, and size, of course, it will be 20. Okay, IDW zinc. Power will be setting it to 2 for second order polynomial. Oh, there's already 2 by default, so it should be fine. Search radius should be variable, and number of points is 8 because we're considering the sample points nearest to 8. And then just simply click OK. Then it's completed, and we can see the interpolated raster using IDW method. Now how can we do using natural neighbor method? Let's choose the natural neighbor tool, search for natural neighbor, input soil nutrients data, Z value, it should be again ZN, zinc, and we will be naming it zinc 20. Okay, so after completing, we can also see the output by natural method, as we can see here, natural neighbor method. Now let's interpolate by using spline method. There's one called regularized spline method and another tension. So let's do first by regularized spline method. Okay, so let's search for spline, and just have to remember the weight. We'll be putting it to 0.1 and number of points will be 12. Z value zinc, output raster spline. Should I name it something distinct? Okay, yeah, regular spline reg. Let's just write that. And what else? Yeah, its weight is 0.1 and number of points is 12, so that should be fine. Let's click OK and see the output. Oh, let me just close it first. So this is the interpolation using spline method. Now next, spline method, but now we'll be doing the tension technique. So it's the same, but here instead of choosing regularized, we'll be choosing tension, and input point z value will be zn, and output tension. Okay, you can name it anything you want, and everything should be just like that. Press OK, and then there you go, you can get the tension on. Both look similar, but the method of calculating are different, and you can also see the difference in value. Okay, so next we'll be doing interpolation by the method of trend. We'll be using third order polynomial. Okay, search for trend, spatial analyst tool, zinc, and the output trend. Polynomial order will be using third order polynomial, and rest should be fine. It should be, everything should be the same. So let's press OK, and there we go, we can find the interpolation using trend method. Now we'll be using Kriging method. So for that we need to customize a little bit, so let's look into that first. First, for Kriging, we need to right click the empty space here and go to geostatistical analyst. From there you can go to the drop down and click the geostatistical wizard, or you can simply click this button, because this is the geostatistical wizard, and then under geostatistical method we'll be clicking the Kriging or co-Kriging method. Then select the source data from here, soil nutrient data, make sure that's selected, and data field is zinc. Then we'll press next, and Kriging type simple, transformation type will be using prediction, but the transformation type should be log, and the order of trend removal, let's put it to second. Then we'll press next, and then in this menu we'll be using exponential. Just make sure that's selected, and everything else looks fine. So we'll press next here again. Then here we can see the covariance modeling semi-variogram, as we have studied in the theory. So here's a variogram represented in the graph. Now let's see, here we can see the bivariate distribution. Okay, bivariate distribution, we want to set it to true, and variable, we'll set it to covariance, or you can also change it to semivariance. Okay, and then model nugget, it should all be fine. Let's set the model 1 to spherical. We'll set the anisotropy to true. I hope you're following. And then okay, then we'll be choosing the calculate partial seal as true, and it's already true. Then we can press next. Now when we press next, we see this window. Then there's nothing else to edit, so we can simply press next again. Here we can see what our output will look like. Now we need to adjust few things. The search neighborhood, it should be smooth, and after that we also need to adjust some things like maximum neighbor. Maximum neighbor 8. Okay, it should be standard, but maximum neighbor should be 8 and minimum neighbor should be 2. Yeah, this is fine. I'm sorry about any confusions. So now we press next, and here we can see all the data, but this is what we're more interested in, the predicted errors. Here we can see the root mean square error is 0.13, which is good because the maximum is 0.15, and there are other summaries. So now we can just click finish and save this report. Save. Let's save it to output, spatial interpolation, yeah, and Kriging. Okay, save, and then press OK, and then it's finished. So this is the interpolated raster using Kriging, and we have created using all various methods. These all can be compared. So as we saw in this video, we have created interpolated those points, those limited given points, to fill the values of all the areas surrounding using the raster cells using various methods. Thank you all for watching the video.